the topic that has been given to me is all about atmospheric analysis of particulates in Module 4.3. The sampling and analysis of air particles, as well as analytical methods for analyzing them, are described in this section. So there are two types of analytical methods, those that need sample and those can analyze solid materials directly without the requirement for a dissolving stage. The procedures involving dissolution are reviewed after the solid phase analytical techniques have been briefly defined. So first is measurement and characterization of the particulate content. We have total particulate concentration. It is a measurement of the mass of solid extracted from a fixed volume of atmosphere by filtration or by methods. So these are the typical analytical values. So first is 70 microgram cubic meter in rural air, 300 microgram cubic meter in urban air, 1 milligram cubic meter in factory workshop, and 100 milligram cubic meter in power station flue gases. So for the number 2, we have composition of the particulate. So this involves elemental analysis, particularly for metals, since the inorganic component of the particulate material may be present as insoluble silicate salts. Two approaches are possible for the analysis of these particulates. So this is where elemental analysis comes in. Extreme conditions can be utilized to dissolve the sample, which is then determined using the procedures described in chapter 2.4. For number 3 is determination of particle size distribution. Particle size determination is important because of the following reason. So first is the resident time of particle in the atmosphere is dependent on its size. The smaller the particle size, the greater is the resident time. So the size of a particle determines how long it stays in the atmosphere. Second is particles with a diameter of 5 micrometers have the greatest potential physiological effect, and this fraction of particulate matter is called respirable dust. And when we say respirable dust, it is the practice of assessing pollutants in the volume of air that can be breathed by the employees of a certain workplace. So last is the study of the emission from a particular industrial processes reveals that the particulate matter is often within a narrow size range. So when the pollutants from a certain industrial process are examined, it is discovered that the particulate matter is frequently within a small size range or limit. For the sampling methods, since the concentrations of particulates vary rapidly with time and location, careful sample strategies have to be adopted in particulate sampling. In eternal atmospheres, there is often a measurable vertical variation, even over a few centimeters. Hence, emphasis is laid on personal sampling to assess the exposure of an individual rather than comprehensive survey of background levels. However, for external atmospheres background concentration, using large throughput or high volume samplers remains the most appropriate methods. Because particle concentrations change rapidly with time and location, proper sampling procedures must be used. So there is frequently observable vertical fluctuation in interior atmospheres, even across a few millimeters. So first, the sampling methods is high volume samplers. So the high volume samplers is the most popular method of measurement of the mass concentration of suspended particulates smaller than 10 micrometer. So in this method, a known volume of air is sucked by a high-speed blower through a fine filter. An increase in weight due to the trapped particles is measured. Some procedures require the total combustion of the filter. Others, its dissolution. So typical sampling times range from 1 hour for contaminated urban atmosphere to 24-hour for clean rural atmospheres. The analysis is gravimetric and the particulate level is generally expressed in terms of microgram cubic meter of air. Based on typical results of such sampling, the following example would illustrate the calculation. So these are the following example that would illustrate the calculation. Second is personal samplers. Personal samplers have filter holder clipped to lapel and pump around the waist. The pump is similar in design to those used for organic gas sampling described previously, with one difference gas sampling is at the higher rate of approximately 2 liters per minute through a 25 millimeter filter. Filters are glass fiber if simply a total particulate mass is required. For elemental analysis, depending on the subsequent analytical procedure, other filter material may be used. This apparatus will produce a representative sample of total inhalable or inspirable dust. So glass fiber filters are employed when just total particle mass is required. So depending on the subsequent analytical procedure, other filters materials may be used for elemental studies. This instrument will provide a representative sample of total inhalable dust. For the last one is cascade impactors. In the previous high-volume sampling method, particulate materials are collected by filtration. It gives only the total particulate content in an air sample. Cascade impactors, on the other hand, can be used to determine particle size distribution in an air sample. They rely on adhesion of particulates on a surface. Filtration is used to gather particle elements in the prior high-volume sampling approach. The cascade impactor consists of 5 to 10 collection stages in which the sample airstream is constrained to pass through a series of jets. Smaller particles having lower momentum are collected in later stages, where the jet velocities become progressively higher. The impactors are reported to be capable of sizing particles down to 0.2 micrometer and an efficiency of 100% for particles as small as 0.6 micrometer has been obtained. So it simply provides the overall particles content of an air sample, and that is the cascade impactors.